Now let's look into the second method under feature filter type feature selection, which is chi-square test. Of course, we have looked into the chi-square test in detail. In detail means very detail in our under the section of feature selection, univariate selection, where the statistical significance tests has been discussed. Okay, here so this can be categorized into feature selection using statistical significance test, or you can deal with as a separate feature selection algorithm also. It has both ways. So that's why here we will have a quick overview of this. We won't be going in depth because here we will use it like an algorithm. So there we have done the detailed chi-square test, basically statistical significance test, and here it's just a simple algorithm. So how can we use it as an algorithm? That's what we're gonna see here. Okay, so chi-square test is a statistical test used for filter type feature selection, specifically for categorical data. It measures the independence between each feature and the target variable in a classification problem. So that's what we're specifically talking about here. So let's look into the definition, how to define the chi-square test. So chi-square test evaluates whether there is a significant association between two categorical variables. It calculates the chi-square statistic and compares it to the critical chi-square value to determine the statistical significance. Then applicability to a data type. The chi-square test is applicable when both the predictor feature and the target variable are categorical variable. So the chi-square test is applicable when both the predictor and the target variable are categorical. So it can be used in both single sample and multi-sample scenarios. So this is the mathematical equation, and we have discussed earlier. So the formula for the chi-square statistic depends on the type of chi-square test being performed. In the context of feature selection, the chi-square test typically uses the chi-square statistic formula for contingency tables. For a 2 by 2 contingency table, so the chi-square can be calculated using this formula. So O sub I minus E sub I, summation of deviations of O sub I minus E sub I whole square divided by E sub I. So here chi-square, what we call it as the chi-square statistic or test statistic, and sigma is the sum of everything, and then O is observed frequencies and E is expected frequencies. So so here O sub I is the observed frequency in the contingency table for the category I of the feature, and category some J of the target variable. And similarly the EI is also same, like it's the expected frequency of in the contingency table calculated under the assumption of independence between the feature and the target variable. Okay, so now let's look into the working procedure. So algorithm working procedure. So it will construct a contingency table and create a table that shows the frequency counts for each combination of categories between the feature and the target variable. So then we will calculate the expected frequencies based on the assumption of independence. So calculate the expected frequencies for each cell in the contingency table. Then we will compute the chi-square statistic So use the formula to calculate the chi-square statistic by comparing the observed frequencies and expected frequencies. Then we will determine the degrees of freedom. The degrees of freedom depend on the size of the contingency table and are used to calculate the critical chi-square value. Then we will move on to the comparison to compare the chi-square statistic to the critical value. Determine the critical chi-square value for the chosen significance level. Example, if it is 0.05 alpha, and compare it to the calculated chi-square statistic. And finally, assess statistical significance. If the calculated chi-square statistic exceeds the critical value, it indicates a significant association between the feature and the target variable. So then now let's move on to the applications. So the best application, obviously, it's a feature selection. In addition to that, we have few more applications. The first one is feature selection. The chi-square test can be used to select the most relevant categorical features for classification tasks. In addition to that, we have text mining and market research. Those are not as important for us data scientists. So let's look into the examples. So we can do the disease diagnosis with this. So examining the association between symptoms and diseases to identify the most indicative symptoms for a particular disease. And similarly, we can go for the market segmentation. So analyzing the relationship between customer demographics and product preferences to determine the most influential factors in a market segmentation. And similarly, we can also look after customer churn analysis, so investigating the relationship between the customer attributes, example age, gender, location, and churn behavior to identify predictors of customers churn. So note that the chi-square test assumes certain assumptions, such as the categorical variables being mutually exclusive and independent observation. So it's important to consider the assumptions and limitations of the test before applying it to a specific problem.